question number 5. We have two particles moving along the x-axis. They give us the position of particle P and the velocity of particle Q, and where particle Q is at time t equals 0. So for part A, when is particle P moving to the left? To know left or right, we have to look at the velocity, the sign of the velocity. So first thing we have to do is take the derivative of x of p. Remember, derivative of a log function is u prime over u. So derivative of t squared minus 2t plus 10 is 2t minus 2 over t squared minus 2t plus 10. We have to find the critical values for that. So that's when 2t minus 2 equals 0, or when t equals 1. We should also check when t squared minus 2t plus 10 equals 0, but that's going to be an imaginary number, so we don't have to worry about it. So there's our number line. We say, okay, 1 is our critical value. When we are a number between 0 and 1, the velocity is going to be negative. When we are a number between 1 and 8, the velocity is going to be positive. So when is this moving to the left? It's moving to the left from 0 to 1. 0 is included because it's not a critical point, and it's the included endpoint of the defined interval. So we include the 0. Part B, we want to find when the two particles travel in the same direction. So we already have how particle P is traveling. Now we have to look at the velocity of Q. We set that equal to 0, get our critical points, and do our number line there. So 3 and 5 are the two times when particle Q is at rest. So we go from 0 to 3, from 3 to 5, and from 5 to 8. When we have a number between 0 and 3, we're going to have a negative times a negative, gives us a positive velocity. When we have a number between 3 and 5, like 4, we're going to have a positive times a negative, gives us a negative velocity, and greater than 5 are both positive, so we have a positive velocity. So let's see, from 0 to 1, they have opposite signs. From 1 to 3, they have the same sign. They're both positive, so they're moving right. From 1 to 3, or in the same direction from 1 to 3. From 3 to 5, they have opposite signs. But then again, from 5 to 8, they're both positive, so they're moving in the same direction. So they're moving in the same direction on the open interval from 1 to 3. And then from 5 to 8, where 8 is included, again for the same reason as in part A, because our interval is defined from 0 to 8 inclusive. So it's not that these things stop moving, it's that we're not paying attention anymore after 8, so we include the 8. So same direction from 1 to 3 and from 5 to 8. For part C, find the acceleration of particle Q at time t equals 2. Okay? Acceleration, just take the derivative of the velocity. Derivative of the velocity of Q is just 2t minus 8. At time 2, sub in 2, and we get negative 4. And we want to know, is the speed increasing, decreasing, or neither at time t equals 2? And explain your reasoning. Well, since our acceleration is negative at 2, and we know from up here the velocity of Q at time t equals 2 is positive, the speed is decreasing because the acceleration and the velocity have opposite signs. Now the last part, the position of particle Q the first time it changes direction. Okay. Particle Q changes direction at time t equals 3. So we want to find the position at 3. So again, we can use fundamental theorem. Position at 3 minus position at 0 is integral from 0 to 3 of v of q of t dt. So we just sub in, we know the position at 0 is 5. Integrate, do a little math there, and we get our position at 3 of particle Q is 23. That part D, I'm not too sure. I think that's, according to what they've posted, that should not be on this year's exams, because supposedly there's not going to be integration with position, velocity, acceleration, but who knows?